Hi, I'm Gary Thomas from the College of Western Idaho, bringing you more math help. Today, we're talking about variables and placeholder parentheses. So the idea is that in math, there are all sorts of things that we need to talk about. And since among all the tribes of humankind, mathematicians are the laziest, instead of writing out long descriptions, complicated things, what we like to do is use little tiny symbols to shorten things for us, abbreviations, if you will. And you've seen a lot of these in math. You've seen things like X for the unknown. You've seen things like A for a constant, ax squared plus bx plus c. If you don't like lowercase letters, you can use capital letters. So capital letters are often used to describe sets. And when you're tired of the alphabet that we use in English, you can go to the Greek alphabet, right? And you can have pi r squared. There's all sorts of Greek letters that are used in a lot of different places in math. Statistics is full of Greek letters. Hebrew letters, so this is a symbol for infinity. You can use English letters with strange marks over them. So X bar is another thing that's used in statistics. Variables are names of things that we don't know the value of. And it was René Descartes, who lived from 1596 to 1650, who suggested that when we want to use a letter for a variable, we should use letters at the end of the alphabet. And this is why we're very familiar seeing X and Y and Z. And what I want to emphasize today is that variables are placeholders. That's all they are. They're taking the place of something that I don't know what to write yet because I don't know what it is. Let me give you two examples. Here are some function definitions. So f, well, there you go, another symbol that you could use. Typically, f and g are used for functions. So if we define f of x as x squared plus 2x plus 3, and if we were to define g of x as 5x plus 4, we do see a lot of these x's, and these are the variables I want to talk about today. And the important key takeaway is that these x's are just placeholders, and in particular, because they're standing for something else, don't ever, ever, ever imagine that this x and this x are the same x. It's a coincidence that we're using the same symbol. But students get confused because they see the x and then later they see the x and they think that these are somehow the same. If you think of them as placeholders, then you won't confuse them. You won't mix them up. And let me show you how I do that myself. I think of a function, f of x, as actually having a certain shape. And so if we wanted to write the function using placeholder parentheses instead of placeholder variables, then our function f of x equals x squared plus 2x plus 3 has a shape where there's something. I don't know what the something is, that's why I wrote x. But if I want to work with it, I need some space to write. I need some space to conceptualize. And so instead of writing x, the variable, I'm going to write placeholder parentheses. So here's the shape of the function, the form of the function, if you want to say it that way. There's something, and you square it, and then you add 2 times something, and then you add 3. And the reason I like this method is I'm not going to confuse this with any sort of x. If I want to know f of x, then I just write in x, and I have my original function definition. If I want to know, say, f of 4, now I'm evaluating the function. The complicated way to do it is to say 4 and put in all these things. Your mind can't do 2 things at once. Let the notation do the work. So start with the shape. Here comes the shape. And then what are we trying to evaluate? We're trying to evaluate 4. Put in the 4, That doesn't take any brains, right? Because the parentheses are there wherever they are. I write in the value, and then I evaluate it. 4 squared, I'm thinking that's 16-ish, and 2 times 4 is 8, more or less, and add the 3, and I think it comes to 27 maybe. Check me later with a calculator. Sometimes I make mistakes. Sorry, no prizes. Anyway, that's how we could do this. And you're thinking to yourself, well, this is baby stuff. I do this all the time. I can calculate these without having placeholder parentheses. Let's move to a more difficult problem, and you'll see where this comes into play. So, what kinds of harder combinations are there? The most common, the most important in algebra is composition. So the idea of composition is we are going to evaluate some function and then take its result and feed it into another function. And typically it's written with this little tiny circle. It's not an O, it's not a degree sign, it's kind of halfway in between. And we pronounce this f of g, and we'll say f of g of x. And what this actually means is that we have f acting on g of x. This notation is a little longer. It's a lot easier to use. Typically your textbook, your tests will write it like this. I always rewrite it like this so that I don't have to work as hard. Let's find out what this means then. If we want to know the value of f of g of x, we can use placeholder parentheses. Here's an f. What does f look like? F looks like this. Yeah, but there's a variable in it, and then there's an x again. Remember, these are totally different variables. It's a coincidence that they have the same name, that they look the same. We're going to use placeholder parentheses to get around that, and composition will be much, much easier for us. So I have something, placeholder parentheses, squared, plus 2 times something, placeholder parentheses, plus 3. I haven't done any work yet. I haven't had to use any of my brains. This is really, really simple. All I've done is copied this. You could have your little 5-year-old brother at home do it. As long as he knows the difference between letters and other things, you say, whenever you see a letter, put these 2 curvy lines and copy everything else, and that's all I did. So I haven't used any brains. Then, what is f acting on? F is acting on g of x. Well, I know what g of x is. It's 5x plus 4. And so again, not having to use any mental ability, I write 5x plus 4, and I've got it. And if the professor wants, I can multiply things out and simplify and combine like terms and those things. But this is the hard part, is setting up the composition and not letting the x's mess you up. So, takeaways from this. Do one thing at a time. I wrote f, just f. I just wrote the shape. I wasn't thinking of g, I'm just doing the f. If you try to write both at once, you will mix them up. And then the second, this is one of my silly slogans I use a lot, is let the notation do the work. This was really, really easy. I didn't have to use brains, and I know it's right. I still have to do some algebra, but I've got it without having to work hard. So here are some trickier functions just because they have fractions in them instead of being simple polynomials. And if we want to compose them, again, use placeholder parentheses, let the notation do the work. Don't struggle because these x's are different. Just don't write the x's until you have to. So here we go. I'm trying to compose f with g. That means f acting on g of x. What does f look like? I write the shape, and the shape of f using placeholder parentheses is that. And then what is it acting on? It's acting on g. G looks like, and I'm just copying it, so notice again, I'm not using any of my brain power. This is nice. This is a relaxing Sunday afternoon jaunt. This isn't a struggle. Well, now there's work, right? Okay, dividing by a fraction means you flip it, right? And so 6 times 2x plus 1. And then you can use the distributive property. 6 times 2 is 12, I'm thinking, and 6 times 1, we're adding this, is 6. And that wasn't a lot of work. Let's really challenge ourselves and go the other direction. So g of f, this is very typical in your homework, right? They'll give you 2 functions, and they'll say, find the composition going one way, and now find the composition going the other way. And we're supposed to notice by doing lots of these that that they don't have the same result. So this time, G, which is a different color, it doesn't matter. I don't have to be perfect. G, it's supposed to be pink. G of f of x, I'm totally lost in my colors. We'll see what we can do. The colors don't matter. You're going to use a pencil when you do these on your own homework. I need to get the shape of G. What does G look like? It looks like 1 over 2 times something. Those will be my placeholder parentheses. So here we go. 1 over 2 times something plus 1. And then the question is, what's the something? It's f of x. That's 6 over x. And again, I'm doing all of this without having to think very hard, which is nice. Okay, now I have to do a little bit of work. That's okay. I'm not immune to work. It's not always my favorite thing to do, but if I have to, I can. Multiplying 2 times 6 gives me 12 over this fraction, over the variable x. Add 1, and then I'm supposed to do some common denominator thing, right? So if I multiply this times x over x, now I've got x's on the bottom, and on the top I have 12 plus 1 over x, which is x, and 1 over something I vaguely recall I'm supposed to flip a fraction like that. And so here I flip the whole thing, I get x over 12 plus x. And there was a little bit of algebra in the simplification, but the setup was a no-brainer. And the setup is the hard part. It's the critical part. If you get it wrong, it doesn't matter how good your algebra skills are in simplifying a fraction. So here's another way to combine functions. This is one of the hardest things in my algebra class. It's also used in calculus, and in fact, the reason that my algebra kids have to do it is because this is really, really important in calculus. If you are one of my algebra students who don't plan to take calculus, then I'm kind of wasting your time, and I apologize for that. But math professors get so excited at this thing because it's so important in calculus that we insist on giving it to algebra students. It's tricky, but I will show you how to use placeholder parentheses and helper brackets, another of my inventions, to make these really, really easy. So first, just to clear things up, it's called the difference quotient, which is a complicated term. Why do math people do this? It's actually simple. Difference means, well, there's a subtraction. Hey, there it is. And quotient means, well, I'm dividing by something. Oh yeah, I'm dividing by h. If you want more details, they're in your textbook. There's a cute drawing of a graph, and it's labeled, and everything's there. It's really the slope of a function, a slope of a graph. This is the rise, and this is the run, and it's rise over run, and you're thinking, oh yeah, that's slope. The hard part is calculating one of these, because that's always what they ask you to do. And the reason it's hard is, well, there's an x, and there's an x, and there's an x. These aren't the same x's. They're placeholders. So to make this simple, when I write f, I'm going to write the shape of f. I'm going to use my placeholder parentheses instead of a variable, and then later I'll write in the x plus h, and everything magically becomes simple. So here we go. I need to write f of something. And I don't care what the something is. I'm doing just one thing at a time, and I'm letting the notation do the work. So here I go. I'm going to write the shape of f. I'm going to do a subtraction. I'm going to write f again. And this one's simple because f of x, I know what f of x is because f of x is it's this. And so all I have to do is write it. The hard part there will be the minus sign, and I'll use what I call helper brackets to take care of that. But let's start with this f. I'm going to write the shape. So the shape is 2 times something squared, I'm using placeholder parentheses instead of a variable name, plus 5 times something minus 7. And again, this isn't hard. I haven't had to use any brains. There's a minus sign. The minus signs are the hardest things in math. I always have this silly slogan: if the math people promise to get rid of the minus signs, then all the English majors could be engineering majors, because it's the minus signs that mess us up. So when I see a minus sign and I know something complicated is coming, I use what I call helper brackets. And helper brackets are just muscular parentheses that allow me to write something complicated, and then I can use the distributive property later and get it right without having to strain my brain. So there's a minus sign, I've put in my helper brackets, and here comes f of x, and I know what f of x looks like. I don't even need to use placeholder parentheses, I can just write it. 2x squared plus 5x minus 7. What's supposed to go in here? X plus h. It says x plus h. Again, I'm not using my brains. This is really, really easy. Let the notation do the work. I write x plus h, I divide everything by h. And then, yeah, you have to simplify, you have to use distributive property, you have to be able to square something. But from here it's just algebra. This was the hard part. This is the part I've seen students over and over again get wrong, because this x and this x confuses them, and sometimes they write the x plus h and sometimes they don't. Sometimes they just write the x and sometimes they just write the h. If you let the notation do the work and use placeholder parentheses, then the setup is easier, no matter how complicated f of x is.